Hey guys, stat 1150. The purpose of this video is to begin what's called hypothesis testing. And let me just say one thing before I get into this too much. You know, I know it's so tempting sometimes to bypass the videos and go to my math lab and just do the help me solve it. And you know, I just encourage you not to do that. You know, I've taught this class over 100 times. If there was an easier way to teach any of the content, I think I would have figured it out by now. So guys, just suck it up, watch all the videos, and replicate the way that I do the problems. Hypothesis testing is a continuation of inference, and you know, we've seen this goofy drawing so many times. It's probably wearing you out, and you just want to fast forward when you see this. But once we get into big boy, big girl statistics, we examine the relationship between samples and populations. And we saw that if we have population information, we can determine the likelihood of getting a particular sample from that population using probability. Well, we've changed over the last few videos to investigate inference. And inference is the study of statistics that uses information from a sample to make an inference about an unknown value in a population. Now, an example of that, if we want to estimate, and again, in this direction, the things that are in the population are unknowns. So if we wanted to, for example, estimate a value for an unknown average in a population, then what we would do is we would go out and take a sample. In this case, it would be a sample mean, and we would use it to estimate the unknown value of the population mean. If we were dealing with a percentage, categorical variables, we would take a sample proportion and use it to make an estimate of a population proportion. Now, I'm not going to go into all the reasons why, but because of sampling variation and things, we have error, so we need to build in margin of error and to investigate what we've taken a look at here recently called confidence intervals. So confidence intervals are one technique under the heading of inference, inferential statistics. The second technique is hypothesis testing that we start today. And the two types of hypothesis testing problems that we're going to learn how to do, as you might expect, are for a mean and a proportion. Now, guys, hypothesis testing, I'll tell you, it's one of my favorite things to teach, and I think it's one of my favorite things to teach because it's so applicable to, you know, further studies in statistics. So let's kind of keep it simple first of all, and let's just talk about some essential ingredients of hypothesis testing. First of all, you know, just what the heck is a hypothesis testing? I like to think of it as a procedure that we use that enables us to choose between two claims. Let's say you've got a tricky brother or sister who loves to come up with these games that they know they can win, okay? And let's say they come up to you one day with a very, very simple game, and they're like, okay, I got this coin here, let's flip it 100 times, and every time I get a head, you owe me $1. Every time you get a tail, I owe you $1. And you think, well, you know, fair coin, you know, that's not a big deal. So you flip this, and you end up getting like 80 heads and only 20 tails, and you end up, what, owing your brother or sister $60. Well, that wouldn't be cool. Well, there's two claims going on here. Your brother or sister might make the claim that the coin is fair, and you might make the claim, hey, I'm getting screwed here, right? The coin is not fair. So we have two claims here, and hypothesis testing allows us to collect sample data and make a decision on which of these claims is most believable based on randomness and probability. So pretty cool stuff, actually. Now, the way that I teach hypothesis testing is I teach it via 4 steps. So it's going to be a very, very rigid 4-step procedure. And some people are, they're more artsy and they're more creative and just, too super cool to follow directions. If you're one of those people, this is going to drive you crazy. Because guys, I'm going to tell you, wham, bam, thank you, ma'am, this is exactly what I want done, and in this order. So, first step, you want to state your hypotheses. Now, a hypothesis is typically an educated guess, right? But in our context of hypothesis testing, a hypothesis is a claim about a measurement. Okay? So that's going to be the first thing. And I'm going to teach you more about this in this video. The second thing you do is you set up your test. Now what we do in this part is you just really kind of prepare your test to be conducted. You're going to check assumptions, you're going to check conditions, and you're going to establish your line in the sand. So check conditions and establish Now, what in the world do I mean by the line in the sand? Well, if you make a claim about something that should happen and you go out and take a sample and your sample measurement is different than your claim, then, okay, if it's different and really, really close, then you might say, well, it's not enough evidence to think that the claim is false. But if you collect something and it's a long way away, then you might have reason to believe that the claim is not true, that it is false. So you've got to establish this line in the sand that kind of establishes, okay, it's close enough to the claim to not discount the claim, or it's far enough away from the claim to discount the claim. So we establish that line in the sand. The third thing you're going to do is you're going to collect your data, and you're going to compare it to the claim. So let's say that let's go back to this illustration about your brother having this coin, and he says it's fair and you think it's not. So your claim is that 50% of the time you should get heads. So you sit and you flip this coin, so you collect your data, and you found that 75% of the time you got a head. Well, is 75%, considering that these values that you collect randomly, that they're going to fluctuate, and we talked about that back in the confidence interval, is that too far away from 50% to think that the coin is fixed, that the coin is not fair? Well, what if we got 60%? What if we got 45%? What if we got 52%? What if we got 53%? Guys, we got to establish our line in the sand to know when this value is too far away from the claim for us to believe that the claim is true. So we collect the data and compare the claim in the context of the line in the sand that we established in step number step number 2. And finally, in step number 4, you state your conclusion. All right? Now, let's talk more about these hypothesis testing and the hypotheses. I put hypotheses plural because there are 2. Okay? First of all, hypotheses are statements about population parameters. So what this tells me is my hypotheses can only include mu or p. It cannot include x bar, sx, or p hat. These are values, these are notations that deal with sample statistics. They aren't included in hypotheses. Hypotheses are only about a population mean or a population proportion. Second thing, again, never made about a sample statistic. Third thing, we have 2 hypotheses. The first thing hypothesis that we have is called the null hypothesis, and the notation for it is H sub O. Couple things about the null hypothesis. This is kind of the neutral statement. It's kind of the status quo. It's the less skeptical statement. Typically, the null hypothesis represents no change or no effect of a treatment. On the other hand, the alternative hypothesis denoted H sub A. Somebody wants to ask me, says, well, I see the A and I see the A, so that kind of makes sense. But I see the N, I see the O, that doesn't make any sense. Why isn't this H sub N? Well, I don't know, but it just isn't. The notation that we have here are H sub O and H sub A for the 2 hypotheses that fall under our global heading of statistical hypotheses. So this is what I think the more aggressive statement. And ultimately, what you want to test. So that's the alternative hypothesis. Guys, it's important enough to repeat. Hypotheses are statements about population parameters, and they are not statements about sample statistics. If you ever see something like this, where someone makes a statement of H sub O, where X bar is a particular value, that is completely wrong. Hypotheses are always statements about a mean value mu or a proportion value p. You never, ever, ever see X bar, p hat, sample statistic notation included in hypothesis. Now, the best way I think to learn about setting up null and alternative hypotheses are to look at examples. But guys, let me give you the skeleton first. The null hypothesis is always presented as an H sub O, a colon, the parameter equal to a value. The alternative hypothesis is always H sub A, colon, the parameter, the value, and a competing statement, less than, greater than, or not equal to. Guys, in this case, in our case for 1150, we keep it kind of simple. The only parameters that we can put here is mu or p. Now, let's look at examples. The ACT for SSU students is an average of 21. The chair of the math department feels the average ACT for math majors is higher. What's our null hypothesis? The claim. What's the alternative hypothesis? Well, as I said up here, whatever parameter is used there has to be there. So we used mu, so mu has to be here. Whatever value is here has to be here. And then we choose one of these statements that represents what we want to test. Since this chairperson wants to test that the average ACT is higher, then we would put a greater than there. Now, same statement here, but let's change it just a little bit. The chair of the math department feels the average ACT for math majors is lower. Well, the null hypothesis is still the value of the status quo, 21. The alternative hypothesis still uses the same parameter, still uses the same value, but it uses the inequality from up here that represents what we want to test. Third example, C. The average ACT for math majors is different. Status quo, mu equal 21 from the problem. H sub A has to be the same parameter, has to be the same value, but different doesn't imply greater than or less than, it just implies not equal to. So what conclusions, what generalizations can you conclude, right? What can you conclude here? One thing I can conclude is in the null hypothesis. First of all, it always deals with a parameter and never a statistic. And the next thing I can conclude, it's always equal to. And it's always equal to the value of the status quo. In this case, it's the ACT for all Shawnee State University students. What can you conclude about the alternative hypothesis? Same parameter, same value. There's just a difference in the inequality that you use based on the way that the problem is posed. All right, look at another example. You really feel there's something up with your brother flipping this coin, okay? And so if it's a fair coin, then 50% of the time, the result will be a head. Okay, is everybody okay with that? Problem number 1. You suspect the coin and feel that the percentage of heads is higher than 50%. Got two statements here, don't you? The null and alternative hypothesis. What goes first? The parameters. Well, guys, we're dealing with a problem here not about a mean, but about a percentage. So we use P. From what we established previously, we know there's always going to be an equal sign there. The value of the status quo is going to go right here. Whatever value is there has to go here. Now we come in and find the competing inequality that represents what we want to test. In this case, it's higher. So we have greater than 0.5. B, you suspect the coin and feel that the percentage of heads is lower than 50%. H sub O is the status quo, if everything's fair. H sub A is what you'd like to test, is less than 50%. Part C, or example C, you suspect the coin and you feel it's unfair. You don't really know whether the percentage of heads is higher or lower than 0.5. You just don't think it's going to be 0.5. You just don't think the coin is fair. But you're not making any directional statement like you are right there. Okay? Now, guys, we've seen previously that gestation periods follow a normal distribution with 266 days mean, 16 days standard deviation. A doctor feels for some reason that women in his region have gestation periods that are less than what's been provided for all gestation periods for all women. Feels it's less. What would be the mean, the null and alternative hypothesis? Well, we're dealing with the mean, so it has to be mu. This always has to be equal to. This always has to be less than, greater than, or equal to. We'll choose one of those. This has to be the mean of the status quo, and whatever goes there has to go here. So really all you got to do is come in and choose the inequality, and I think the way I set it up, the doctor felt that the women in his area had a mean gestation period that was less than everyone else. So the alternative hypothesis would be less than 266. Reports show that 38% of people believe in ghosts. I don't know if you've ever done this or not, but I've done it. These ghost walking tours, like in, I think I took one in, gosh, where was it I took it? I think it was in Savannah, Georgia, and took another one in Charleston, South Carolina. So let's say someone thinks that this is going to be higher for people who have just completed one of these ghost walks, okay? And we want to test it out to see if this person's claim is believable. So we're dealing with the percentage, always equal to the status quo. But someone would like to test, so that's what our alternative hypothesis is all about. Someone's ready to test. Percentage, same number, is higher after people complete one of these ghost walks. So gang, at the end of the day, remember that your null hypothesis will always be a parameter equal to a value. The alternative hypothesis will always be the same letter. It will always be the same number, but it will have a competing inequality that represents what you would like to test. So guys, that's all I got. Next video, we're going to get into actually conducting these things, and you know, if you'll let me teach you, I think it's extremely doable. So take care.